For what value of lambda is the function defined by this particular set of expression continuous at x is equal to 0? What about the continuity at x is equal to 1? So they're asking us to check the continuity of the function and also find the lambda actually. So for what value will the function become continuous? So given for what value of lambda, okay, we'll consider, or not given actually, let's consider the function to be continuous at x is equal to 0. So from this I can infer that f of 0 will be equal to limit f of x as x tends towards 0 from the left hand side and limit f of x as x tends towards 0 plus. Now when I substitute, I have the following scenario. Right? So all I have to do is consider what's happening at different scenario. At f of 0 we have this following expression, then the left hand side too is the same expression, while the right hand side is a different expression. We have that to be 4x plus 1. Now when I do substitute it, when I do direct substitution, so on direct substitution, so what and all happens? Well, this is lambda times of 0, because wherever x is there I'm putting 0, so we don't get a different answer. Now we have limit, sorry, limit is gone, we are applying the value direct substitution. This too is lambda times of 0, and over here we have 4 times of 0 plus 1. When I solve this, I get 0 is equal to 0 is equal to 1. No, this does not make sense. So we can tell that as the above result is a false statement. This implies f of x is discontinuous at x is equal to 0 for any value of lambda. So we can't have any value that we can put in lambda to make it continuous basically. So the language, it's supposed to be that, but anyways, this two infers the same. So it's left to you guys how do you want to frame it, but yes, we can't miss the word false statement. So I hope you guys remember false statement in linear equations and all, we have learned that. Now we are looking at the continuity at x equals to 1. So x is equal to 1. Okay, so this expression is the only expression that is related to x is equal to 1, and it's a polynomial expression, so we can directly take f of 1 will be equal to 4 times of x plus 1. We're going to substitute x is equal to 1 and we end up with 5. Then we have limit f of x as x tends to 1. Again, we're not taking left hand side and right hand side because it's the same expression throughout. And so this also leads to 5 on direct substitution, and this is equal to f of 1. And what can we infer from this? From this we can infer that f is continuous at x is equal to 1. Okay guys, so this might be something new for few of you guys. False statement is a scenario wherein we are equating two different things, two set of numbers which are not the same, or we have a relationship like 1 is not equal to 1. That's also a false statement, right? 1 is equal to 1. Or something like inequality like 2 is greater than 10. That's also a false statement. So such scenario are known as false statement.